Well, I think that the primary thing to understand is that the last half of the 20th century, in which most of us played out our careers and so forth, was largely built around physics and electronics and high-speed communication and creating large infrastructure, electricity, power, roadways, and so forth. This new century, at least its early decades, are clearly going to be centered around the amazing advances in life science, in information technology, and very small-scale physics, so-called nanotechnology. It is the merging of those three things that creates the amazing and interesting opportunities. But at the same time, if we think of that as the frontier of things that are smaller and smaller and faster and more complex, at the same time we have another great frontier that's of terrific interest to the lay public. And that's what I call macro systems engineering. This is the domain in which the energy crisis needs to be resolved, in which we need to move forward to stop global warming and mitigate its consequences, where we worry about production on a global scale, our communication systems, the delivery of health care, logistics. So sort of the very small, the very large. Both are increasingly complex. Both have deeper and deeper scientific underpinnings. And I believe that the public needs to understand that we have these two very important frontiers that are largely, though not exclusively, driven by science and engineering. And the big payoff that we look forward to is bridging from the small scale to the large scale, so that I'm convinced that the great challenges that this current and next generation of engineers are going to be able to deal with are the creation of biofuels, of designing things that can be manufactured and used with much smaller environmental footprints, in increasing the efficiency and the personalization with which we deliver health care. These are the grand challenges in my view, and this honestly is the most exciting period in human history in both science and engineering.